root of y to the fourth root of 81, and the fourth root of x to the fourth. Excellent. So I'm using rules number 2 and rule number 3, actually. Good. And then what do I get at the top? Very good. I'm told everything is positive, otherwise I would have used the absolute value. Good. And then the fourth root of 81. Which number I raised to the fourth power? 3. Yes, very good. Times x. Now, let me show you how
Is that not an absolute value?
we were told in this problem that everything is positive.
Oh.
Otherwise, yes, we would have put the absolute value. Absolutely. I would like to show you how to determine, let's say, a cube root or a fourth root with a graphing calculator. So what I do and what I like to do is, if I'm asked, let's say, find the fourth root of 7. Okay, so let me write that to make sure what we are trying to do. So we want to find the fourth root of 7. Well, this is the same thing with 7 raised to which power? Indeed, 1/4. It has to be a fraction if it represents a radical. Excellent. So that's one way. That's not the only way. So I prefer writing 7 caret in parentheses 1 divided by 4, and I'm done. It's 1.626576, blah, blah, blah. The other option is you put the index first, and then you go to math, and then scroll down to number 5. That's not what I meant. So 7, go to math, and scroll down to 5. You can just type 5. Okay, and then you put in, it was the fourth root, sorry. So 4, math, and I want 5, and now the fourth root of 7, and when I click enter, I get the same thing. For me, this is way more long. It's longer for me to go to math and put in the index first, and then math, and then scroll down to 5 and click 5. And for me, it's easier to put 7 to 1/4. So you have 2 options. You choose the one you like. Okay, moving on. Our next rule, I forgot where we stopped. Which number did we stop at? Was it 6? I think it was 6, and I think the next one is 7, isn't it? Six, yes. So number 7 now. All exponential rules are valid for fractional exponents. And I'm going to list a few. A to the nth power times a to the mth power is a to n plus m. If these are fractions, I use the same rule. A to negative n is 1 over a to the nth power. If it's a fraction, I still use the same rule. A to the nth, everything to the mth power is a to n multiplied by m. So if these are fractions, the rules will be the same. No change there whatsoever. So on page 601, and all the rest are valid. On page 601, we're asked to simplify some radicals. So let's see how we can do that. And let's start with problem 47. In problem 47, we have y to 1/3 divided by y to 1/6. How do I divide two exponential notations having the same base what do I have to do? Subtract, indeed. So I copy the base, and from the exponent of the numerator, I subtract the exponent of the denominator. Now the difficulty is, versus the previous situation, this one with, integers, is that I have to deal with fractions. So I need to find the least common denominator. What is the least common denominator of 1/3 and 1/6? Good, which means the first fraction, the top of the first fraction has to get something. What does it get? A 2. So then 2 minus 1. So this will be y to 1/6. Now if I ask you, please change it back into into a radical. How will you do that? Exactly. The 6th root of y raised to which power? Exactly. The 6th root of y to the first. Very good. Let's look at a few more. Let's say 45. 3 to 1/4 multiplied by 3 to 3/8. I copy the base. What happens with the exponents? Very good. 1/4 plus 3/8. The least common denominator is? Very good. So this one gets a 2. So it's a 2 plus 3, which is 3 to 5/8, which is the same thing with which radical? The 8th root of 3 raised to the 5th power, and I know that 3 raised to the 5th, I can replace it. 3 to the 4th is 81, and so that's 243. Because it's not such a big number, I can write it. Okay.
So either answer is acceptable?
Absolutely. Let's look at problem 12.
Professor,
Yes.
they don't have the same base. It's 3 multiplied by 4.
Very
Do we
good question.
multiply both?
You can't. I'll give you an example in a minute.
I don't remember that rule.
I'll show you in a minute.
Okay.
Very good question. So, problem 12, 16x to the 8th power, everything raised to 1/2. Obviously, I have to take each piece and raise it to 1/2. So I have 16 raised to 1/2, and I have x to the 8th raised to 1/2. Yes, 8 over 1 times 1 over 2 is 4. So the only thing I have to perform is basically the square root of 16, which is 4x to the 4th. Very good question. So here it is. If I have 2 to 1/3, and I have multiplied by 3 to 1/2, right? How do I do this? This is no exponential rule right here till I show you the next step. But right now there is no exponential rule because we don't have this. They don't have the same base and they don't have the same exponents. Okay, very good. So then I know that the least common denominator, I cannot add or subtract. But if I were to add or subtract these two fractions, the least common denominator would have been 6. So I have to change this into denominator 6. How do I write that? Very good. I have to change this one into denominator 6. What do I write that? It's 3 over 6, right? Now, both of them have the same denominator, which means they both have the same what? Index. So then this is 2 squared and this is 3 to the 3rd. And now I can multiply them because I will say the 6th root of 4 multiplied by 27. I'm sorry? Sorry. So then this is the 6th root of 8 and 2 to 108. So that would be the only way to multiply these two. Only after I change their exponents into the same denominator, so they can become the same index, and then I can multiply two radicals with the same index. And that is actually a perfect question because I forgot to mention one thing. It's clear, but I should have mentioned it, and your question just reminded me of that. See, this rule, like all the other rules, this rule goes this way, but it can go this way as well. So if I'm given a product of two radicals, I can rewrite it like this, and this is exactly what we just did. So I can go back and forth. So this is exactly the case. This is the 6th root of 2 squared, and this is the 6th root of 3 cubed. I'm allowed to multiply them because they have the same index, and that's how I wrote this. So all those rules, thank you for your question, all those rules go from left to right and from right to left. The ones that are valid, not the one with the sum or the difference, because that's not allowed.
So basically, 16x are two separate numbers.
Here? Oh,
16ax.
you're talking about this and this?
Number 2 goes to the number 12. Yeah, that one.
This is a product of two quantities. So this is basically the square root of this. But it's easier if you say, I take this portion and raise it to 1/2, because that's one of the exponential rules. And I take this portion, I raise it to 1/2. So this is like, for example, 2 times x to the 3rd power. You have 2 to the 3rd and x to the 3rd. So I applied power 1/2 to 16, and I applied power 1/2 to x to the 8th. So because it was easier to separate it. So then this becomes the square root of 16, which is 4, and this becomes 8 times 1/2, which is 4. So that doesn't have a radical anymore. Better? Okay. Very good. Let's look at 51. I know I have 6 more minutes. I'll stop in 6 minutes. So 51. B to 1/2 times B to 3/4 divided by negative B to 1/4. So the negative goes in front. Can anyone tell us what to write for the numerator? B raised to which power?
2/4.
So I have 1/2, yes, but I have to show it. You're right. 1/2 plus 3/4. I don't want to perform it just yet because I have a division now. So I copy the base, and what happens with the exponents? I want to do everything in one step, if possible.
So B and 1, it's just B.
True. So B to 1/2, yes, plus 3/4 and minus 1/4.
Yes.
So from the exponent of the numerator, I subtract the exponent of the denominator to do it in one step. Yes, I need to find the least common denominator, and that happens to be 4, and this one needs a 2. So 2 plus 3 minus 1, 5 minus 1 is 4. 4 over 4 is 1 indeed, so this is negative B. Any questions? Any questions?